Welcome back, everyone, to the deep dive. You know how sometimes you wonder, is it better to buckle down and just learn something all on your own? Or is it smarter to try to team up with other people? I feel like we all kind of go back and forth with that.
Totally. I mean, it feels like it should be obvious, right? Like one way is better than the other.
Yeah.
But when we really got into the research on this, it was pretty surprising how much nuance there is to it.
Yeah, we found this super interesting study. The title is kind of a mouthful. It's a cognitive load approach to collaborative learning, United Brains for Complex Tasks.
That's the one. It's a really dense read, but I think it does a great job of getting to the heart of like when and why you might pick one learning strategy over the other.
So just to lay the groundwork here, we're talking about research in educational psychology, the science behind how we learn, right?
Exactly.
And I think a lot of us, we've all been there. We've had times where we just, locked ourselves in a room and crammed for a test or tried to learn a new skill all by ourselves.
Yeah.
And then other times we've done group projects or study sessions with friends.
Right.
And today, what we're really going to do is dig into, what does the science actually tell us about which of these approaches, solo or group, actually leads to better learning? And the big catch is it kind of depends.
It does depend. So for a while now, there's been this huge push for collaborative learning.
Everyone's all about collaboration.
Oh, yeah. It's like the magic bullet for everything. And the idea behind it, I mean, it makes sense on the surface, right? Like when you're discussing things with other people, you're arguing different perspectives, you're reflecting on your own ideas. In theory, all of that is leading you to process the information more deeply. And so you're going to end up with supposedly a richer understanding.
Okay, so the thinking is that by talking it out, you're actually going to learn it better.
Right.
But you mentioned that the research on this isn't as clear as you might think.
Yeah, that's the thing. I mean, everyone loves the idea of collaboration, but when researchers actually compare individual learning to collaborative learning, they don't really get a clear winner. Like, it's not as simple as saying, oh, collaborative learning is always better. The evidence is really all over the place. And the study we're looking at today, they actually say that it's really difficult to make these unequivocal conclusions about whether collaborative learning is superior to individual learning. It's not so simple.
So let's break down some of those findings, because I think it's useful to know, what have researchers found that's positive about collaborative learning? What's so appealing about it?
Sure, there are definitely some promising benefits, particularly when it's done in a well-structured way. So first of all, you tend to see learners getting more engaged. They're more into it when they're working with others. And that often translates into longer retention. So they remember the information better. And you also see collaboration fostering those, what they call higher order skills. So critical thinking, problem solving, those sorts of things. Plus, when you're working collaboratively, there are opportunities for self-directed learning, like you're negotiating meaning with each other, you're having to explain your reasoning out loud, and you have that built-in support system from the other people in the group. So it's not all just like happy sunshine. There are some downsides that researchers have found.
So what's the catch?
Well, it's not as simple as just throwing a bunch of people together and hoping for the best.
Yeah.
There's a lot more to it than that, because there are definitely some potential pitfalls, some real challenges. For example, sometimes groups will just totally underutilize information.
What do you mean by that?
So there's this thing called the base rate information, which is basically just information that's readily available, like the answer's right there in front of you, but for some reason the group just doesn't see it or use it effectively. And then you have this thing called the sunk cost effect, where you're so invested in a particular approach that even when it's clearly not working, you keep going with it. You don't want to admit that you've wasted all that time and effort.
We've all been there.
Right. And then another issue is ineffective information sharing. So sometimes individual members of the group have this crucial knowledge, this information that would really help the group, but they just don't share it. It's what researchers sometimes call hidden profiles.
Oh, interesting.
And then you also have things like production blocking, which is basically just the mechanics of group conversation getting in the way of learning. You have to wait your turn to speak, so you might lose your train of thought, or someone else might jump in with a different idea before you get a chance to fully explain yours. And of course, there's the classic social loafing problem, where some people just coast along and don't really pull their weight.
So it sounds like even if you control for all those group dynamics issues, the research on collaborative learning still gives you this really mixed bag of results.
It does.
So If it's so hard to get a straight answer about whether collaborative learning is better, what are some of the reasons why it's been so difficult to research?
Well, the study we're looking at points to 4 key characteristics of the research that make it kind of messy.
Okay, let's hear 'em.
The first is that a lot of the research uses what they call indirect testing. So they're not actually measuring learning directly. They're looking at like how well the group performed on a task during the learning process, or they're observing the group's interactions. But that doesn't necessarily tell you what each individual learner actually took away from the experience. A group might do really well on a presentation, but that doesn't mean that everyone in the group actually understands the material.
That makes sense. Like one person could carry the team.
Exactly. And sometimes the process of collaboration itself can actually interfere with individual learning. Like if you had just had those individuals working alone and then pooled their work together, they might have learned more.
So it's not always a given that the act of collaborating actually boosts learning.
Right.
Okay, so that's indirect testing. What's the second issue?
The second one is that a lot of the research relies on naturalistic studies, which means they're doing the research in real-life classrooms and learning environments.
Makes sense.
So that's great for seeing how things actually play out in the real world, but it makes it really hard to control all the variables. Like you have all these cognitive factors, motivational factors, social factors all mixed together. So it's hard to tease apart the specific impact of collaboration on learning.
Right, because there's so much else going on.
Yeah.
Okay, what's the third one?
So the third characteristic is the focus on surface level characteristics. Like a lot of studies will look at group size, whether it's online or face to face, the type of task, like is it a case study or a problem solving task? But these are just surface features. They don't really tell you about the deeper nature of the task itself or the learners involved.
Got it. So it's not just about the logistics of the collaboration.
Yeah,
You have to think about the actual material they're learning and the people in the group.
exactly. And then the last big issue they point to is this tendency to compare group performance over individual contributions.
Okay, break that one down for me.
So a lot of studies will compare how well a group performs against like the average performance of individuals working alone. But the problem with that is that a group might do better just because they have more people, right? Like they can combine their knowledge and skills. So it's not necessarily a fair comparison. What they suggest is comparing to what they call a nominal group, which is basically just a statistical way of combining the work of individuals who worked independently.
So like you're pretending they work as a group, but they actually didn't.
Right. And what's interesting is that some research has found that actual collaborating groups will perform at the same level or even worse than these nominal groups.
Wow.
Yeah, which suggests that sometimes collaborating can actually make it harder for individuals to learn and remember information.
Okay, so given all of these like difficulties in getting a clear answer about collaborative learning, it feels like we need a different way to look at this whole thing. Is that where cognitive load theory comes in?
Exactly. Cognitive load theory, or CLT, is really helpful here because CLT focuses on the limitations of our cognitive architecture, specifically working memory.
So working memory, that's like our mental workspace, right? Where we're
Mhm.
actively thinking and processing stuff.
Yeah, exactly. It's like the RAM in a computer.
Limited capacity.
Exactly.
Okay, so how does this tie into the question of solo versus collaborative learning?
Well, CLT breaks cognitive load down into 3 types. The first is intrinsic load. And that's basically just the inherent difficulty of the material itself. Like how many elements are there? How complex are the relationships between those elements?
Okay, so some topics are just harder to wrap your head around than others.
Right. Like trying to understand the stock market is going to have a much higher intrinsic load than like memorizing a list of vocabulary words.
Okay, what's the second type?
The second type is extraneous load. And this is cognitive load that's imposed by things that aren't actually helpful for learning. Like imagine a textbook that's poorly designed with confusing diagrams and stuff, or a lecture that's just all over the place.
So extraneous load, that's stuff that just makes it harder to learn, but it's not actually making you understand the material any better.
Right. It's just noise, basically.
Okay, and what's the third type?
The third type is germane load. And this is the good kind of load. This is the mental effort that you're putting into actually making sense of the material, connecting it to what you already know, and building those deep mental models, what they call schema construction in CLT.
So this is where the real learning happens.
Exactly. And the important thing is that these 3 types of load, intrinsic, extraneous, and germane, they all add up. And if the total load exceeds the capacity of your working memory, then you're not going to learn effectively.
Okay, so if you're already dealing with a lot of intrinsic load, like the topic is just really complex, then you have less mental space left over to handle any extraneous load, like a confusing textbook, or to engage in that deep processing that leads to real understanding the domain load.
Right. And that's where the idea of the group as an information processing system comes in.
Okay, let's talk about that.
So, the basic idea is that when you have a group working together effectively, you essentially have multiple working memories available, like you're pooling your cognitive resources.
Interesting. So it's almost like you're distributing the mental workload.
Yeah, exactly. And there's actually some interesting research on how our own brains do this. Like when we're tackling really complex tasks, our brain will actually split the processing between the left and right hemispheres.
Wow. So it's like our brains are already doing this kind of collaborative processing internally.
Right. It's called interhemispheric processing. And the idea is that by dividing the labor, you can actually process information more efficiently.
So if you apply that to collaborative learning, then it would make sense that for really complex tasks, it could be beneficial to have a group working together because you're essentially expanding your working memory capacity.
Exactly. But, and this is important, there's also a cost to coordinating all of those brains,
Right.
all the communication and stuff. And what the brain research suggests is that for simpler tasks, the cost of coordination actually outweighs any benefit you get from dividing the processing.
So if the learning material isn't that complex to begin with, then all the discussion and back and forth in a group might actually be creating more cognitive load than just working on it individually.
Yeah, exactly. Because if the intrinsic load is low, then you as an individual learner can probably handle it just fine on your own. And all the extra stuff that comes with collaboration, like having to wait your turn to talk or trying to make sure everyone's on the same page, that just becomes extraneous load. It doesn't actually help you learn better, it just makes it harder.
Okay, this is starting to make a lot of sense. So the key factor here is really the complexity of what you're trying to learn.
Right. And that leads to the central hypothesis of this cognitive load approach to collaborative learning, which is that the more complex the learning task, meaning the higher the intrinsic load, the more effective and efficient collaborative learning will be. Conversely, for less complex tasks, individual learning is probably going to be more effective, both in terms of how much you learn and how efficiently you learn it.
So if you're trying to learn something really complicated with lots of moving parts, then having a group of people to share the mental burden and discuss different perspectives is a huge advantage.
Right.
But if it's something more straightforward, like memorizing facts or learning a simple procedure, then just focusing on it individually might be the smarter approach.
Exactly. Because for those simpler tasks, the what they call transaction costs of group work, the time and mental energy you spend on communication and coordination, those costs don't really contribute to understanding the material any better.
So they're basically just wasted effort.
In a way, yeah. But for complex tasks, those same processes of discussion and explanation, they actually become crucial for learning. They become germane because the group needs those processes to make sense of the information together, to come up with solutions, and to reach a level of understanding that they wouldn't be able to achieve on their own.
And this is what the research actually shows, right? Like the study mentions that for simple recall tasks, individuals tend to outperform groups. But for more complex problem-solving tasks, groups often do better than individuals, and even better than those nominal groups, the ones where you're just statistically combining individual work. So that suggests that for complex tasks, collaboration is actually boosting learning.
Exactly.
Okay, so what does all of this mean for like how we approach learning in our own lives and in classrooms? Like what's the practical takeaway from this complexity matters idea?
Well, I think the biggest implication is that educators and learners should be really thoughtful about the complexity of the task when they're deciding whether to use individual or collaborative learning strategies. If you're dealing with something that's intrinsically complex, then you should definitely consider collaborating because that shared cognitive load can make a huge difference.
And on the flip side, if you're a teacher who's planning to do group work, you need to make sure that the tasks you're assigning are actually complex enough to warrant collaboration.
Right. Like if it's something that students could easily do on their own, then putting them in groups might actually just be creating unnecessary obstacles.
Makes sense. So it's not about always doing group work or always doing individual work. It's about being flexible and choosing the approach that's best suited to the material and the learners. All right, so to sum it all up, the effectiveness of learning alone versus learning with others really boils down to how complex the stuff is that you're trying to learn. If it's super complicated and challenging, then pooling your cognitive resources through collaboration can be a game changer. But if it's more straightforward, then the focus and efficiency of individual study might be the better way to go.
That's a great summary. So, as you continue your own learning journey, or if you're working with others who are learning, just keep this whole idea of cognitive load and collaboration in mind. Because understanding how those two things interact can really help you optimize your learning strategies and create more effective learning environments.
So think about the stuff you're trying to learn right now. Is it really complex? Does it have a lot of interconnected pieces? If so, maybe try finding some people to collaborate with. It could make a huge difference in your understanding. On the other hand, if it's more straightforward, then maybe just buckle down and focus on it solo. The important thing is to recognize when it's time to unite those brains and when it's time to leverage the power of one. Thanks for listening to The Deep Dive.
Thanks, everyone.